so well, my name is Theo de Campos, and I'm just going to give an introduction to database management system, which is actually a very important topic in computer science. Well, I'll try to make it in a way that is okay for those who are not into computer science, but actually this topic is completely new to me, even though I've done computer science. Right, so data, well, we use data and generate data all the time, especially these days with, everyone have their mobile phones, smartphones, and we know we're all users of IT resources all the time. And we always check or download things or look for information everywhere, so that's where the importance of data set is. They are everywhere. Basically, well, databases, they're just a collection of data that is integrated. And well, here are some examples of structured data and like the sort of things we use every day, like the Wikipedia is a very, well, it's basically a data set. It's an encyclopedia structured in a data set so that people can search things and find them easily. Even like online calendars, email applications, news repository. Well, sorry, Learn is a data set system as well. And well, they can be quite, well, they can be massive in the order of terabytes, or like if you think of YouTube or Facebook or well, even Google in general, they actually rely quite heavily on data sets and database management systems. And yeah, so well, they are huge, and they have to be quite reliable and even accessible for everyone. And well, basically the idea is that databases, they model entities like students' courses, attendances, and grades, and the relationship between those entities, like telling that a person is enrolled in a course. That's basically modeling relationship between entities. And that's how data is modeled. And so the idea of the database management systems is to essentially make access easier and enable us to quickly access data and modify and check things and all that. So the database management system is a software package and a computer system designed for that. The efficiency is crucial. So even if you have the most powerful computers, like given the scale of the data, you still take ages just to do simple things like locating a person when you type their surname in the university data set and you want to send them an email and you don't actually know the exact email address, you just look for a name. If the data is not structured, it takes a long time, even for a powerful computer. So it's important to structure the data in a nice way and make it retrievable quite quickly. And well, so the information needs to be structured, and the systems need to be safe, reliable, they need to cope with multiple users and be convenient to use. So a bit more motivation, essentially, well, they enable data independence. So the way we use data shouldn't depend on how the data is stored. So it's not like finding a file in your computer. It's actually quite hard sometimes, so ideally just want to query something and get the results straight away. So and those systems, they need to ensure the data integrity, and well, and they help from the developer side. They're designed in a way that they help to be managed. I mean, it becomes easier to manage them, and developing new applications become faster as well. So yeah, so in realistic systems, they need to deal with, do things in parallel, because essentially searching for data in a hard disk takes a long time. So you could actually do several things in parallel. So while you search for a bit of information, you could be addressing another user's request. But when you do things in parallel, you tend to get confused, and that happens with computers as well. So we need to manage the data in a way that reduces inconsistency. So anyway, the basic element of data sets and database management systems is the transaction, which is basically an atomic sequence of actions, essentially querying or reading and writing data to the disk or to a set. So each transaction, well, being atomic, they should run sort of independently, and if the data set is consistent before the transaction happens, they need to remain consistent afterwards. So, well, the users here, I mean the actual designer of the data sets, they can specify what it means to be, what makes the data set sort of, what are the integrity constraints, and the system then tries to enforce them automatically. Right. So, well, here's one example. So given the data set, you have a set of transactions, and the system tries to ensure that the execution of a set of transactions is actually equivalent to some serial execution of those transactions. So even if they are requested at the same time. So yes, because sometimes transactions need to access the same bit of data, and one of them modify some bit of data, and so this could actually lead to inconsistency. So before actually reading or writing an object, a transaction needs to request a lock of that object, which is just a bit of data, and then it can work on it, and then it only releases the lock when it finishes working on it, or reading or modifying it. So here's, well, it's an example of actually bad scheduling. So you have two transactions here. This first transaction wants to read data A, do something, and then write again data A. Imagine this as a file that this transaction modifies, read, and then write it. And imagine that another transaction wants to read A as well, write A, and then do other operations and commit, meaning indicated finished. So A and B as well. And the first one also wants to do that. So if we schedule it in the way it's shown here, you get this inconsistency problem. So the example here, let's say in a bank application, you want to transfer $100 from A to B, and at the same time there's another process from the bank itself that wants to add 6% of interest to both A and B, the two account holders, let's say. This task, this transaction is essentially trying to execute the transfer from A to B. So it reads A, subtract that $100, write A minus 100, and then reads B, add 100, and then write B. And this one is doing two operations that are sort of independent, but if this happens while this is in the middle of still working on it, you get two different results on the balance of in the account of A and B, which is something you don't want. So what this says is that while this transaction if this transaction needs A and B, it should sort of lock those two bits of data, do the whole thing, and then free it so that this transaction can then apply the interest to both of them. So there are several strategies to solve this kind of problem, and it can get a lot more complicated. You can have multiple transactions trying to access the same bits of data, and you can have this transaction requiring A and B at the same time as this one requires, well, A and B. Well, it's a similar case. So one remains locked by the other. So there are several strategies to deal with that. So yeah, this just gives a hint of how to ensure atomicity. So, like I said, all actions in document transaction happen or non-happen, so we should ensure that everything is complete, or it's better not to touch the data. And well, the systems, the servers, they normally keep a log of everything that happens by all, and everything that all the transactions do with a data set, so that if something goes wrong, the system can automatically sort of read that history of events and then recover data or recover the previous state of the data set. And this whole thing is done in a way that to try to ensure that it's safe. So writing this log is the highest priority task, and yeah, and even if something is not, so a transaction is not actually written to the log, you just bring the data set to the state that it was before. So in principle, no one should lose data. But obviously every transaction has a cost, so sometimes the designer doesn't dedicate so much processing to managing all the possible things that could go wrong, and that's when we have massive crashes and things like that. So the systems themselves, they are designed in a, well, they follow a sort of architecture that's layered. So, well, this is quite a detailed thing, but you can represent the data itself, like, well, used to represent as a hard drive here, which is just a block of data written in a disk. And then from this bit, which basically just have bytes written in a way that's kind of almost meaningless, you have different layers of abstraction. So at the bottom layer, you have a system that just manages the disk space and ensure that we don't run out of space, or space is reused in the disk in an efficient way. And then there is this part here, which is buffer management. So essentially, reading and writing to a hard disk is something quite slow. So that's why with computer systems, they tend to load things into memory and then operate into the RAM sort of memory of the computer. And only after some things are done, they get flushed into the hard disk. So well, we need to manage when to load things to memory, when to flush them into the hard disk and things like that. And then, as you get up to higher level, you start dealing with files and access methods, and then this is like relational operations, so which is that bit I mentioned in the beginning about dealing with how data relates to each other, how queries relate one entity to another. And this is actually closer to what the user actually deals with. So when you type something in Google and it's actually trying to autocomplete, it's essentially this autocomplete happens because it has a very powerful query optimization process there that sort of uses some heuristics to find out which are the most likely words to complete what you're typing, and that's where the query optimization happens. And well, these blocks here, they all have to take care of the concurrency control, which is the kind of things I wrote before about well, avoiding data getting locked and all that. So this is, yeah, actually a higher level description of it. There are, there's obviously a lot more to each of these blocks here. I'm not going to keep detailed, but this would be something for another seminar, and the idea would be to zoom into each part of that. Well, so in summary, the databases, they organize information and make data usable. And the management systems, they're just, well, whole systems, which are the computer systems plus the hardware, the actual structure of the data, that they ensure that the databases are fast, reliable, they can be used by multiple people, they are resilient, they will be safe. So like, there's not, yeah, it tries to prevent data loss and all that. So, well, there are some references which I used for these slides, and yeah, this concludes it.
Thank you very much. Has anyone got any questions for Taylor?